So we have baking soda mixed with sugar, and then now we're lighting it on fire. So we have molecules of sugar. Sugar is C12H22O11. So that means it's made out of 3 elements, and it has 45 atoms. And it is, when it combusts, so when it burns, it changes to 12 carbon atoms and 11 water molecules. And the water molecules are given off as steam and vapor. So this is sugar, and there's 3 elements. So there's carbon, hydrogen, and oxygen. But there's a lot more atoms. So there's 12 carbons, 22 hydrogens, and 11 oxygen. So if we add those together, we get 45 total atoms. Now over here, so these are the reactants, these are the products. So there's a 12 out in front of this C, which stands for carbon. That means that there's 12 carbons. And then over here, this should say 11. So this is 11 times 2. Okay, so this is like the distributive property in math. So this 11 is multiplied by the hydrogen, so that would be 22 hydrogen. And then this 11 is multiplied by the oxygen, which really there's only 1. And so that means that there's 11 oxygens. So if we add those together, we get 45 again. And so if you notice, conservation of mass, there's 12 carbons, 22 hydrogen, 22 hydrogen, 11 oxygen, 11 oxygen. So that's conservation of mass. The molecules of baking soda. Baking soda is 2NaHCO3. So that's made of 4 elements and has 12 atoms. When it combusts, it gives off Na2CO3 plus carbon dioxide, which is CO2, plus water vapor, which is H2O. So for the baking soda, this over here is baking soda. So these are the reactants, these are the products. Over on this side, remember this is like the distributive property. So this 2 is times sodium. So that means I have 2 sodiums. 2 times 1 hydrogen, so that's 2 hydrogens. 2 times 1 carbon, so that's 2 carbons. And then 2 times O3. So I take 2 times the 3, that means I have 6 oxygens. So then I add those together. 2, 4, 6, plus 6 is 12. So there's 12 atoms total. The elements, there's sodium, so that's 1. Hydrogen, that's 2. Carbon is 3. Oxygen is 4. So there's 4 elements, but there's 12 atoms. So if we look over here at the products, we have sodium carbonate. So we have 2 sodiums, 1 carbon, and 3 oxygens. In this one, we have another carbon and 2 more oxygens. That's carbon dioxide. And then we have 2 hydrogens and 1 oxygen for the water. So if we add all those up, 3, 6, 7, 8, 9, 10, 11. Oh wait, I wrote 0 for oxygen. There's 1 oxygen. Okay, so that's 12 total atoms. So that's conservation of mass. The same elements and atoms on both sides. Same number of atoms on both sides. So as we're looking at this is a chemical change because it's giving off light. There's definitely a change in temperature, so you can feel the warmth, the radiation from the side. There's definitely a change in odor, kind of smells like burnt marshmallows. There's an unexpected color change. So we have a white powder that is changing to black and also produces gas. So if you look close, you can see little holes inside the black, and that's where the gas was. There's not really a loud sound produced for this one. So because this one is releasing energy, it's an exothermic reaction. The reason why we have sand, that's the brown down below, it is non-flammable and it's an insulator. So it kind of keeps the thermal energy from going down through into the table. And then underneath that we have a metal pan. The metal pan is also not flammable, and it can transfer the thermal energy really quickly. So any thermal energy that does make it through the insulator can be dissipated or kind of spread out through the metal pan, and so that way it can cool off. The metal pan will cool off quicker and get rid of some of that thermal energy into the atmosphere. The orange flame is the sugar and baking soda burning, and then the blue flame that's starting to flash, that's the fire juice. It's starting to run out. So this is after it's all done. You can see this is just carbon that's left, like the element carbon, number 6 on the periodic table. And so the reason why we put baking soda in there is to produce a lot of bubbles. The sugar produces some bubbles, but the baking soda produces more. And so this is what it looks like afterwards. That's what the inside looks like. And it's surprisingly soft and kind of fluffy.